Hello, good evening, students. My name is Aman Kumar Rai, and today I will be taking a live doubt session lecture on the topic of structure analysis. I hope you all have gone through the pre-recorded lectures that are there on the Ekeeda platform, and I hope you all are ready with your doubts. Whatever doubts you have, you can post it in the chat box, and I am here to answer all your doubts. Those who have not yet joined the Ekeeda platform, those students can subscribe on the Ekeeda platform, and there is also a discount offer using the coupon code GOLD11. For those who are new to this platform, let me tell you how this platform works. Once you have taken the subscription, then there will be pre-recorded lectures and you can go through those pre-recorded lectures. And at the end of the week, there is one doubt live session lecture that is being organized by Ekeeda. And there you can post all your doubts. And I'm here to answer the doubts on the topic of structure analysis. So once again, I welcome you all and let us get this session started. So what I have done is I have noted down the syllabus of structure analysis. So in the last two lectures that I have taken, I have told you about the brief syllabus that is there. So in the previous two lectures that I have taken some very interesting questions on the topic of determinacy and indeterminacy of structures. I hope you all have cleared all your doubts regarding this topic and this topic. After these two topics, what I have done is I have taken the topic of force method of analysis, displacement method of analysis. I have told you that how and which methods we use to analyze the beam or analyze the truss. And in these two methods, which one we should use and which one we should use like depending upon the structure condition. What happens is if you choose the right method to analyze the structure, then not only it will save your time, but it will also help you to analyze the structure in a very efficient way. You can also save your time and energy, and also you can save a lot of calculations that are going to be there to solve the question. Then we have the topic of truss analysis. In truss analysis, I told you that there are two types of trusses basically. First one is determinate trusses and second one is indeterminate trusses, right? Then I told you about first one is determinate and second one is indeterminate trusses. Then I told you that how these two trusses should be analyzed. I told you about the method of joints. I have taken a lot of numericals to let you know that how to solve these topics. Then I have taken some numericals from the topic of method of sections. So these two sections are basically used to analyze the determinate trusses. Similarly, to determine the indeterminate trusses, you have unit load method and Castigliano's method, etc. So using these methods, we can analyze the indeterminate trusses as well. Right, guys? Now we are left with the topic of influence line, matrix method of analysis, arches and cables. So this matrix method of analysis, this topic is also more or less similar to the topic of displacement method of analysis. So there in displacement method of analysis, what we study is we basically study three methods. First one is slope deflection method, right, guys? First one is slope deflection method. Then what is the next method? Next method is MDM, that is moment distribution method. So moment distribution method is the most easiest method, or this is the most suitable method for solving the numericals in GATE examination. Right, guys? So I always prefer this method. Similarly, there is this method also, that is the matrix method. So in this matrix method, it is again a displacement method of analysis. So in this matrix method, there are two types of matrices. First one is flexibility matrix. And what is the another one? Another one is static matrix. So here you can, easily solve using the concepts given and using the methods, you can easily solve this analysis, these, questions based on the matrix method also. Then we have arches and cables. What we study in arches and cables is basically, let us say this is one simply supported beam and here is one arch like this. So let us say we want to, calculate shear force or bending moment at this point after a distance of x. So there you will see that how to calculate these forces. So today what I have done is I have noted down some basic and very important questions and some interesting numericals as well from the topic of influence line. I will try to cover this topic, and then after covering this topic I will try to take some questions on these two topics as well. So guys, I hope you all are ready with all your doubts, and whatever doubts you have, you can post them in the chat box, and I am here to help you with all your doubts. Okay guys, so this is all about the syllabus of structure analysis. Now let me tell you that what is the weightage of structure analysis in GATE examination. So this I have already told you in the previous two slides as well, in the previous two lectures as well, that the topic of structure analysis covers almost 7%, right guys? So how much is 7%? You all know that the GATE examination is basically of 70 plus 30 marks. So what is 70 marks? 70 marks is of technical paper, right? And what is 30 marks? 30 marks is of aptitude and maths, right guys? So I hope you all are aware of it. Now what is the 7%? 7% is of the 70 marks, so it will be nearly, 7% of 70 is 4.9. So let us say that somewhere around 6 to 8 marks are asked in the GATE examination. Now let me tell you that these 6 to 8 marks, these are confined numericals, or basically or mostly asked in a simpler way, right? In the paper of ESE, if you see, then this topic of structural analysis is asked on a different level altogether. But in GATE examination, this topic is asked on a very simpler level, or very basic level. So you don't need to prepare, in depth regarding this topic. What you need to do is you need to get the basic idea and try to solve the basic numericals that are there in this topic. So what I have done is I have taken down some numericals on the topic of influence line diagram, and I will help you in solving the questions that are there. And in between, if you have any doubts, you can post it in the chat box, and then I will once I see these doubts, then I will be able to answer these doubts. Okay. So shall I start taking the questions that I have noted down? I have noted down some very basic questions first, and depending upon the time limit that we have, I will try to cover as much as possible. Okay, guys. So let us, take you through the first question. So this is the first question. In BMD and SFD, can anybody tell me what is BMD and what is SFD? What is BMD and what is SFD? I hope you all are aware of these two terms. You must have studied these two terms in the topic of strength of materials. Strength of materials is nothing but SOM. So what is BMD? BMD is nothing but bending moment diagram. It is a very basic question, but a very conceptual question. So you need to understand it very well so that you don't have any confusion in these two topics. And then the topic of ILD, right? What is ILD? ILD is influence line diagram. ILD is influence line diagram. And what is SFD, guys? SFD is shear force diagram. What is SFD? SFD is shear force diagram. Now, you try to answer this question that in BMD and SFD, out of these four options, which option is the correct option? Yes. Can anybody? I will give you some time. Just go through the question, analyze it, and then let me know if you get any answer. Yes. Just take your time. Take 1 or 2 minutes. Good evening, Shwani. Good evening, MBGE Sports. Okay, so any answers for this question, guys? Please tell me if anybody has got any answers for this question. Okay, let me tell you. In BMD and SFD, let me just take you through what is. I have already told you BMD is nothing but bending moment diagram, and SFD is nothing but shear force diagram. So, if anybody remembers how we used to draw, let us say this is a simply supported beam. What is this? This is nothing but a simply supported beam, right, guys? This is what a hinge support, and this is what a roller support. Yes. Now let us say there is one reaction P that is acting here. So can anybody tell me how can we draw? Let us say we want to draw the SFD and DMD of this beam. So how do we draw the shear force diagram and bending moment diagram? Let us say this is point P. Let us say this is SFD and let us say this is DMD. So can anybody tell me how will be the shear force diagram of this beam? It will be simply like this. This will be minus, this will be plus. And can anybody tell me how will be the bending moment diagram of this beam? Yes, guys, it will be simply like this. I hope you all are aware of it. This will be nothing but what? P by 2. This will be P by 2. Here, this will be what? PL by 4. Let us say the length of this beam is L. So what we have done is we have drawn the shear force diagram and we have drawn the bending moment diagram. So while drawing the shear force diagram and bending moment diagram, let us go through the options. Points remain fixed, position of load changes. So can anybody tell me, have I changed the position of this load? Yes. While drawing the shear force diagram and while drawing the bending moment diagram, have I changed the position of this point? I have not changed the position of this point. It means the load that is applied on the simply supported beam is, fixed load. So position of load remains fixed. Here, what it is saying that position of load changes. So it is not correct, right, guys? Position of load never changes. What changes is points change. See here, at first we have taken, let us say, some x1 point. Then at x1 point, what is the shear force diagram that I can get from here, right? Let us say that at x1 point, the shear force at x1 will be how much? Minus P by 2. Yes, can we see from this diagram, right? Similarly, at x1, let us say this is alpha. So at x1, bending moment at x1 is how much? Plus alpha, right? So what happens is the position of load remains fixed. This position of load that is applied as a point load, it remains fixed. But what changes is the points changes. So always remember, in bending moment diagram and in shear force diagram, what is the difference between this and this? The difference is in this one, the position of load remains fixed and the point changes. So what will be the correct option for this one? Correct option is option B. Right, guys? In bending moment diagram and in shear force diagram, the position of loads remains fixed, but the points changes. Now let us see what will happen in ILD, that is influence line diagram. The next question is, in influence line diagram, which of the following option is correct? So can anybody tell me what is the difference between ILD and what is the difference between BMD and SFD? Now let me tell you through an example. See here, let us say that let us say this is a simply supported beam. This is point A. This is point B. Right, guys? This is point A. This is point B. Now let us say that at this point, let us say here, let us say this is L by 2 and this is L by 2. This is point C, right? Now what we want to draw, we want to draw ILD. ILD means influence line diagram for shear force at point C. What we want to draw? We want to draw influence line diagram for shear force at point C. Now let us say this is point C. So how to draw the shear force at point C? Are you all aware of the principle of Muller-Breslau? I hope you all have heard of this principle. This is the principle we use to determine the influence line diagram. I hope you all guys are aware of this principle. So what does this principle say? That if we have to determine the shear force at point C, then we need to apply one Roller's reaction here, right? So this reaction will move in downward direction and this reaction will move in upward direction, and we will apply a unit load of magnitude 1. We will apply a unit load of magnitude 1. So can anybody tell me that how the diagram will be made for this one? Let us say that this is point A, this is point B, and this is point C. So what will happen? This roller support will go down in this side and this will go up in this side. So it will be somewhat like this, right, guys? This is minus, this is plus. Now, what is the ordinate at this point? The ordinate at this point is how much? Let us say here it will be what? Plus L by 2, and here it will be minus L by 2, right? So now can anybody tell me what I have done is I have kept the point fixed. See, I have kept the point fixed, but in this case, my load is changing, right? The shear force is traveling from here till here, right? So what happens is once we keep the point fixed and the load changes, then the diagram that we draw is known as what? Influence line diagram, right? So in influence line diagram, what will happen? The point remain fixed, position of load changes, right? Let us say if we would have been asked to calculate the shear force at any point, let us say at this point, then from this diagram, if I know this L by 2, then I can calculate alpha because this theta is going to remain same, right, guys? So always remember that in ILD the point remains fixed but the position of load changes. If anybody has any doubt in this one, kindly ask me. See here, in bending moment diagram and in shear force diagram, what happens in BMD and SFD? The points change, but the position of load remain fixed. How? See, this position of load is remaining fixed, but the points changes. But what happens in ILD? In ILD, the point remains fixed. Like in this one, our fixed point was point C, and the position of load changes. That is, the shear force is applied right from A till point B, right? So this is the basic difference between ILD and SFD. Right, guys? So I hope I have made it clear to you all. And if you have any doubt, please ask, or else we'll move on to the next question. So let us see the next question, guys. So next question is, for drawing ILD, what value of test load is assumed? See here, I told you that while drawing ILD, what I have done is I have taken a unit load of 1 kilonewton, right, guys? So always remember that whenever we have to draw an influence line diagram, ILD represents what? ILD is influence line diagram. Then we assume a test load and its unit is how much? 1 unit. See here, I have already told you that a unit load of 1 is assumed to draw the influence line diagram. Okay, so I hope we are cleared up to this point. Okay, now let us see the next question. Next question says that ILD of statically determinate beams consists of curve as well as straight lines. State whether the above statement is true or false. So I will give you some time. Just think about it and then let me know what is the correct answer. Either it is true or it is false. And if it is true, then why it is true, and if it is false, then why it is false. You know, I'll give you just one or two, just some time. Just think over it. I have told you some basics here. See, now just think about it, that why or what happens that in a statically determinate beam, if we have curved lines or only straight lines. Okay, just think about it. Just take some time. Okay, I'm waiting for your response. If anybody has any response, please let me know. Just think about that, what happens in statically determinate beam and what happens in statically indeterminate beam, and then try to answer this question, that if there can be a curved line or there are only straight lines. Okay, so just think about it. Just take 1 or 2 seconds. Just take some time, try to answer me. Yes, has anybody answered any question? Has anybody has any answer? False. Who says false? Manoj, you are absolutely right. This statement is wrong statement. This statement is false. Okay, now can you tell me why it is false? Okay, let me tell you guys that there are two types of beams basically. First one is, let us say, statically determinate beam. First one is statically determinate beam. And what is the second one, guys? Second one is statically indeterminate beam. I hope you all are aware of these two meanings of these two terms. What is meant by statically determinate beam and what is meant by statically indeterminate beam. When I say that a beam is statically determinate, then what I mean is I can, calculate the support reactions. Let us say that this one is a beam. So here we have two reactions and here I have one reaction and I have three equilibrium reactions. right? So if I have three equilibrium reactions, then I can calculate these three reactions using these three equilibrium equations. So I say that this beam is statically determinate beam. Now let us say when we say that a beam is statically indeterminate beam, let us say that this is a beam. So in this case, we have total 5 reactions. See here. Now we have total here 3 plus 2, total 5 reactions, but we have only 3 equilibrium equations. So what will happen? We have more unknowns but less equations to solve them. So we say that this beam is statically indeterminate beam. Now what it is saying that ILD of statically determinate beam consists of. Now always remember that if a beam is statically determinate, then if we have to draw the ILD for determinate beam, if I have to draw the ILD for determinate beam, then it is always going to be a straight line. See, just like we have seen in the previous question, that if here is one point C and let us say this is L by 2, then what will be the ILD for this case? The influence line diagram will be like this, right guys? So see, this one is a straight line, this one is a straight line, and this one is also a straight line. So always remember that ILD for determinate beams is always straight lines. Now let us say if this is a statically indeterminate beam. So let us say that this is a statically indeterminate beam, and if we have to draw the ILD for this one, then it can be like this, right? So what happens is these are all curved lines. These are what? Curved lines, right? So it will come only when the beam is statically indeterminate. It will never come when the beam is statically determinate, right guys? So always remember for statically determinate beams, it it will always consist of what? Straight lines, right? So it is saying that consists of curve as well as straight line. So this statement is false. It will never consist of curve line. It will always consist of what? It will always consist of straight lines. Okay. So I hope I am clear to all of you guys. Yashraj says good evening. Good evening, Yash. Okay. So anybody has any doubts up to here? If no doubts are there, then I am moving on to the next question. Next question is, now I have noted down one numerical, very simple numerical guys for you. Try to solve this question and tell me what is the correct option for this one. Here it is saying that this beam AB is of length 1 meter. So let me write down here that the length of this beam is how much? 1 meter. The length of this beam is 1 meter. What will be the equation for vertical reaction at point A? So vertical reaction at point A means here, here will be one vertical reaction. Let us say RA in Y direction. So it is asking what is the value of this RAY, right guys? So can anybody tell me what is the correct option for this one? Try to think over it and try to answer me. I will give you some time. Please let me know what is the correct option for this one. Yes, anybody would like to tell me what is the correct option for this one? Yes, guys, you can do one thing. I will give you one small hint. What you can do is you can take X from point A. Let us say this is point A. So what you can do is you can take at a distance of x vertical load, let us say 1, right? And then try to find out what will be the reaction at point A. Okay, let me solve this question for you guys. Let us say, what I have to first draw. I will have to draw the vertical reaction at point A. So I have to draw the ILD, that is the influence line diagram for vertical reaction at point A, right? So how can I draw? Let us say that this is the beam. Okay. So this is point A and this is point B. And the length is given as how much? 1 meter. So for drawing the ILD for reaction at B, what will happen? So using the Muller-Breslau principle, I can determine it. Let us say this is 1 and this is point A and this is point B, right? So what it is saying is, what will be the equation for vertical reaction at point A? So vertical reaction at point A, the influence line diagram is like this. So how I have drawn this influence line diagram? I will take a unit load. Let us say what I will do is I will take one unit load in this direction. So if I take a unit load in this direction and I will free it from this support. So once I take it upwards and here it will not go anywhere. So this will simply be a what? A straight line like this. So here I have got 1 and here I have got 0 because there is one support here. So at support the vertical reaction is always going to be 0. Now what will be the equation for vertical reaction at point A? So let us say if I have to determine the vertical reaction at any point, let us say at a point that is at a distance of x from here. So what will be the value of this alpha? Can anybody tell me how to determine this alpha? So see here, let us use the similar triangle concept. So what we will do is, let us say this is point C, this is D, and this is E. So in triangle AEB and triangle CDB. See these two triangles. These two are what? Similar triangles, right? Because theta is same. So what we will do is we will write CD upon DB. What will be this DB? This will be how much? 1 minus x. So let us say here this CD upon this DB. This will be equal to what? AE upon AB, right? So CD is how much? Alpha. DB is how much? 1 minus x. AE is 1. And what is AB? AB is 1. What is AB? AB is 1. So from here, can I say that this alpha is nothing but what? 1 minus x. And what was alpha? Alpha is the vertical reaction at a point A. Right, guys? So what will be the correct option for this one? Correct option is option A. If anybody has any doubt in this one, how I have solved this? So what I have done is, first I have drawn the influence line diagram. See, I will tell you the approach. What I have done is, I have drawn the ILD for vertical reaction at point A. So where is this diagram? This is here. Now I have to determine at any distance x. So at any distance x, I have taken value of alpha. Now I need to determine this alpha. So how to determine this alpha? Very simple. How to determine this alpha? by simply using the concept of similar triangles, right? So if these two triangles are similar, it means the ratio of these sides is also equal, that we have studied long back, like, sixth or seventh, I think eighth or ninth class, right, guys? So using this concept, what I have done is I have determined the value of alpha, and how I've taken AB as 1C here, AB is given as 1. So once you write it, you will get the value of alpha. I hope I am clear to all of you guys. If anybody has any doubts, please ask. Yes, I'm waiting for your doubts, guys. I hope you have, gone through the pre-recorded lectures, and I hope you all are ready with your doubts. So kindly let me know. Or you can do one thing. You can simply, I have taken a lot of questions today. So what you can do is you can solve with me and you can tell me whatever answers you are getting, right? So that I will tell you if you're right, if you're wrong. So what will happen is, let us say while solving, you are stuck at some point. Then you can ask me that wherever you have stuck. So if you keep asking me, I'll keep, telling you that where you are going wrong, what should be your approach, how you should proceed, like this. So once you know that how to proceed, then only you will be able to solve these questions. Otherwise, you will be stuck at some point or the other. So let us move ahead, guys. So the next question is, what will be the shape of ILD curve for vertical reaction at point A? I think I have already drawn it. See here, guys. Okay. So can anybody tell me what will be the correct option for this one? What will be the shape of ILD curve for vertical reaction? See, what it is saying is vertical reaction at point A, and ILD curve shape we have to tell. So see here, in the previous slide, I have told you that this is going to be the shape, right? This was A, this was B, this was 1. Here I had taken alpha, right, guys, at a distance of x. So what is the shape of this ILD? This ILD is for what? This influence line diagram is for what? For vertical reaction, for vertical reaction at point A. This is for vertical reaction at point A. See, at this point A, we had taken a vertical reaction in y direction. So I will apply 1 unit load in this direction and see that what will be see here it will be 0. So we will join these 2 points. So this is nothing but what? This is a triangular shape. So what should be the correct option for this one? Correct option is option A, that is triangle. Right, guys? So anybody has any doubts? I've already solved this question in the previous slide. So I think I am clear to all of you guys. Yes. So if anybody has any doubts, please ask or see the next question. So it is very interesting question. It was asked for, 1 marks in the GATE examination. So this is a question from the previous year GATE. So if anybody would like to tell me what is the correct option for this one, I think I have already, told you some or the other point related to this question. So try to think it over and try to tell me what is the correct option for this one. Yes, anybody would like to answer? Okay, the question says the influence line for the structural function is used for obtaining maximum value because of, first one is uniformly distributed load only, single point load, series of concentrated load. So anybody would like to tell me what will be the correct option for this one? Okay. Any answers? I'm waiting for you guys. Okay, so let me tell you. Let us say if I have to draw the influence line diagram, see here, influence line diagram, right? So influence line diagram, let us say that this is a simply supported beam. Okay. So first option says that the load is what? Uniformly distributed load. So uniformly distributed load means what? The load will be applied, let us say, in uniformly like this over the beam. So let us say this is UDL of 5 kilonewton per meter. So I can always, determine the what we have to determine. We have to obtain maximum value of structural function. So this structural function can be of three types. First one is what? Vertical reaction. First one is vertical reaction. Second one is shear stress. And third one is what? Third one is bending moment. Third one is bending moment, right? So what the question says is, if we have to, determine the influence line and we have to determine the maximum value of these three, these structural functions only, if we have to determine the maximum value. So can we do it for uniformly distributed load, single point load, or series of concentrated load? So see, this is for UDL. Now next is, let us say, if I take a simply supported beam and if I take a single point load like this, right guys? And let us say the third option is, this is one simply supported beam and we have a series of concentrated load, right? So let us say this is a series of concentrated load. Let us say this is 10 kilonewton. Let us say this is 10, this is 15, and this is 20. This distance is how much? 2 meter, and this distance is again 2 meter, right? So in these three cases, right, this is the three cases or the different types of loadings we can have. That is the uniform distributed load, then single point load, and then series of single point load. So in all these three different cases, we can draw the ILD. What we can do is, I can draw the influence line diagram. So this influence line diagram, this can be for anything. Let us say this can be for a vertical reaction at point. Let us say this is point B, or let us say in this case, the bending moment for point C, or let us say in this case, the bending moment for point D. So in all these three cases, what we will do is, we will first determine the influence line diagram and then we will apply this load on this influence line diagram. Once we apply the load on this influence line diagram, we will know the ordinate of that influence line diagram and then we can calculate the maximum value of that stress function or the maximum value of that structural function, right? So we can always calculate the maximum value of this structural function for either uniformly distributed load or single point load or series of concentrated load. So in all these three cases, we can determine. So the correct option is what? Option 3, that is A, B and C. So if anybody has any doubts, kindly let me know guys. Yes, any doubts if you have, please tell me. So I hope I have made myself clear. I hope you all have got the correct option. Let us move on to the next question. Okay. So the next question is, Muller-Breslau principle for obtaining influence lines is applicable to. See, there are three options. First option is statically determinate beams and frame. Second option is statically indeterminate structures, the material of which is elastic and follow Hooke's law. Third option is any statically indeterminate structure. So if anybody would like to tell me the correct option for this one. Yes. Any answers from you guys? Please let me know. If anybody has any answers for this one, I think I have, this question you must have seen somewhere or the other. So whosoever are present or whosoever are attending this section, this lecture, live, they can answer this. You can post your answers in the chat box, right, guys? So what will happen? You can always guess. It will be either correct or wrong. So it doesn't matter. What matters is you should always attempt, right? So if you will attempt, then only you will know that where you are going wrong. If you will not attempt, then how you are going to know that where you went wrong? So always attempt, because gate examination is not more than 3 months away. So if you have to see your preparations, how well prepared you are, then you must attend these lectures, post your doubts, and you should solve some questions and ask your doubts, that where you are stuck while solving those questions. So this is going to help you only. Okay, so someone says, Raju says that option 5. I don't think that option 5 is correct. Option 5 is not correct. Anyone would like to tell any other answer? One option is already eliminated. So 4 options are left. So anybody would like to, guess any other options? See guys, option 2 and 3, either statement 2 is correct or statement 3 is correct. If statement 2 is correct, then statement 3 is automatically false. And if statement 3 is correct, then statement 2 is automatically false, because it says both of them says statically indeterminate structure. So if this principle is applicable for statically indeterminate structure, then if it is applicable for any, then this one is false. If it is not applicable for any, then this one is false. So either it will be option A or it will be option 4, right? So let me tell you what is the correct option. So first I will tell you that this Muller-Breslau principle, why this Muller-Breslau principle is used. I think we already know that it is used for what? Drawing ILD. ILD is what? Drawing influence line diagrams. So this, for drawing influence line diagrams, what happens is the beam, whatever beam and frames you are taking, those beams and frames should be either statically determinate. It should be what? Statically determinate. So the first condition is it should be statically determinate. And if it is not statically determinate, and let us say if it is statically indeterminate, so it can be used for statically indeterminate structures as well. But there is one condition, that if we want to, draw the ILD for statically indeterminate structure using the Muller-Breslau principle, then what happens is the material, which material? The material of beam or frame. The material of beam or frame. It should be what? It should be elastic in nature, right, guys? It should be elastic in nature and it should follow Hooke's law. I think you all remember what is Hooke's law, right, guys? So either it should be elastic or it should follow Hooke's law. Hooke's law is what? Stress versus strain diagram. So for this only, for the material which follows elastic or Hooke's law, in those materials, in those statically indeterminate structures only, this Muller-Breslau principle is applicable. Otherwise, it won't be applicable. So what is the correct option? The correct option is option 1. That is, statement 1 and statement 2 are correct, and the third statement is false. Okay. So I hope, Raju, you have got the correct option now. And if you have any doubts, you can, ask me again. So let us move on to the next question. So this is very simple, I guess. All of you can answer this. Come on, guys. Tell me what is the correct option for this one. Just now we have seen that what should be the correct option for this one. Static influence line diagram, ILD, can be obtained by influence line diagram for redundant structures can be obtained by. So which theorem or which principle we use for determining the influence line diagrams? Just now, from starting only we have seen this. So Castigliano's theorem is there, Muller-Breslau principle, unit load theorem, all of the above. So can anybody tell me what is the correct option for this one? I think all of you can answer this question, right? Yes, I'm waiting for your answer. Yes, anybody would like to tell me what is the correct option? I think all of you know this answer. Please tell me what is the correct option. Just now I have told you. See, wherever we have studied ILD, I told you that which principle we use. See, here I told you Muller-Breslau principle. See, ILD, Muller-Breslau principle. So which principle we are using? See here, Muller-Breslau principle. So what should be the correct option for this one? Influence line diagram for internet structures can be obtained by which principle we are going to use? We are going to use Muller-Breslau principle, right, guys? So whenever we have to obtain the influence line diagram or ILD, we are going to use this Muller-Breslau principle, right? So let us move on to the next question. So now I have taken one numerical. So can anybody tell me how to solve this numerical? Okay, I'll give you some time to solve this numerical. So kindly go through it. Yes, anybody would like to tell me what is the correct option for this one? We have to determine the maximum compression in the member, right? So you can see which one is in tension and which one is in compression. And whatever is in compression, we have to determine the maximum compression in the member. So anybody would like to tell me what is the correct option? Okay, guys, take your time. Try to solve this question. Then I will solve this question here. Yes, guys, has anybody solved this one? This is very simple question. Okay, has anybody solved this one? I'm still waiting for any of your answers here. Okay, so let me solve this question now. So let me tell you how to solve this question. See here. Okay, so let us say the ILD for a force in a truss member is shown in the figure. So what is this diagram? This is what ILD, that is influence line diagram. And it is for what? It is for a truss member, right, guys? Now, what it is says is a uniformly distributed load UDL of intensity 30 kilonewton per meter longer than the span. So let us say that the span is of how much? 4 meter plus 4 meter plus 8 meter. It means 16 meter span is there. So our UDL, whatever we are going to apply, this UDL is greater than this 16 meter span. Right, guys? So our UDL is 16 greater than this 16 meter span. And this UDL is of how much? 30 kilonewton per meter. So let us say we are going to apply a 30 kilonewton per meter of UDL, which is greater than 16 meter span. Then the maximum compression in the member is. So we have to determine what? Maximum compression. So see here, there are two things here. This is what? Compression, and this is what? Tension. See here, tension it is written. So tension is above this, baseline. Whatever is above, it is in tension. And whatever is below this baseline, this is in what? Compression. So can I say that here it is in compression? Now what we need to determine is what is the area of this one. So once we know that what is the area of this one, then we already know that we are going to apply a load of how much? 30 kilonewton per meter. So this load of 30 kilonewton per meter, and we have to apply, we have to determine what? Maximum value. See here, we have to determine the maximum value. So if we need to determine the maximum value, then whatever this load we are going to apply, this we are going to apply only up till what? Only up till this point. Why? Because if you apply this load this side, then here it will be compression, here it will be tension. So this tension will, neutralize this compression. So we don't want to neutralize any compression value. So if you have to determine the maximum value, whatever UDL we are going to apply, we are going to apply in this portion only, right? So see, this load of 30 kilonewton per meter, we are going to apply up to this point, right? And it is greater than 16 meter. So this 30 kilonewton per meter load of UDL is going to be applied in this portion only. Now the question remains is how to find out the, area of this triangle. So let me draw the diagram here again. So let us say that we have to, find out the area of this portion. So how to find out the area of this portion? Yes, can anybody like to tell? This one is 0.58. This one is 0.29, right? And let us say from here till here, this is 4. Similarly, from here till here, this is 4. And from here till here, this is how much? 8 meter. Now let us say if you have to determine the area of this, let us say this is A, this is B, and this is C. We have to find the area of triangle ABC. So we need to determine this distance. So let us assume that this distance is how much? Let us say this is X and this complete is 4. So this distance will be how much? 4 minus X, right? Now we need to find this value of X. So can anybody tell me how to find this value of X? See, what I can do is I can apply the similarity of triangle. So how to apply the similarity of triangle? Let us say if we apply the similar triangle rule. So what this rule says that, let us say this is one triangle. See, this is triangle 1 and this is triangle 2. So in triangle 1 and in triangle 2, how we have to apply? I will say that this 0.29 upon X. Can I say this 0.29 upon X is going to be equal to what? This 0.58 upon 4 minus X. This is going to be equal to 0.58 upon 4 minus X. So from here, what I will get is this 29 will cancel this. It will be 2 here. So 4 minus x is going to be how much? 2x. So from here, 4 equal to 3x. So from here, x equal to how much? 3 by 4. Or x will be how much? 4 by 3. Right? X will be how much? 4 by 3. So from here we have got the value of x. This value of x is 4 by 3. Now, can anybody tell me how to get, you know, this maximum compression? So to calculate the maximum compression, what I will do is, to calculate, now let us calculate maximum compression. So to calculate maximum compression, it will be how much? This is 30 kilonewton per meter load. So this 30 kilonewton per meter is going to be applied to the complete triangle, that is ABC. So here we need to calculate area of triangle ABC. Right, guys? So now let us calculate here the area of triangle ABC. So how to calculate area of triangle ABC? Can anybody tell me how to calculate? Simply, it will be half base into height, right? Half base into height. So see here, what is this height? This is, let us say, base. This is height. So height is 0.29. And what is the value of base? Base, can I say 4 plus x? 4 plus x means 4 plus 4 by 3. So can anybody tell me how much is this value? So let us say, just simply put this value here. Okay, guys, simply put this value here. So it will be how much? 30 into 1 by 2 into 0.29 into, take LCM here. So it will be how much? It will be 16 by 3, right? So this 3 and 2 will cancel this one. This will be 5. So 5 into 0.29 into 16. 16 5s is 80 into 0. So how much will be this? So it will come out around this 23.186. So anybody has any doubt in this one? Yes, I have solved this question. If anybody has any doubts, please tell me. Yes, guys, if anybody has any doubts here, see, I've got the correct option for this one, 23.2. Yes, guys, any doubts you have? So I will just take you through what I have done here. So whenever we have to determine the maximum compression value, what we will do first is we are going to draw the inference line diagram. In our case, ILD was already given. So once we know the ILD, then we are going to calculate the area. So once we have calculated the area, we will multiply it with the UDL and we will get the correct answer. So like this only you have to solve the all the options. Okay, whatever questions we have, like this only, this should be your approach. So let us see the next question, guys. So next question is this: a beam, first see in this one no diagram is given, okay, but enough data is given to draw the diagram. So can anybody tell me how to solve this one? Okay, I will give you some hint. What I will do is I will draw the diagram of the beam. Okay, the data is already given, and using this diagram you have to solve whatever is asked. So let us go through the question. The question says that a beam ABC is simply supported at A and B. So let us say this is a beam, and this beam is what? This beam is simply supported at A and B, right? BC is overhanging. So from here, this is, let us say, point C, and this is overhang portion, right? Span AB is 8 meter. See here, this is span AB and it is saying that this one is 8 meter. Then it is saying that BC is 2 meter. So this span BC, this is of 2 meter. Point D is situated at 3 meter from A. So let us say at a distance of 3 meter here, there is one point D, right guys? Using influence line diagram or otherwise, find the maximum ordinate at D of the influence line diagram for shear at D, right? So what we have to draw? We have to draw the influence line diagram for shear at D, right? So how to draw the influence line diagram for shear at D? I have given you enough hints, right? So first, what you have to do is you have to find out how to draw the influence line diagram for shear at D. So once you know the influence line diagram for shear at point D, then you will be able to calculate the from that ILD maximum ordinate at point D. Right, guys? So take just some time, try to think about it and try to tell me what is the correct option for this one. Right? Just go through it. I have given you hint also. I have drawn the diagram also. Just tell me what should be the correct option for this one. Try to solve it. Try to think about it. Try to go through it. Yes, take some time. Yes. Has anybody got any answers for this one? Yes, guys. Any answers for this one? I'm waiting for your answer. Try to find out how to draw the influence line diagram for shear at point D. If you are able to draw the diagram, then you can very easily tell me the correct option. Okay, I don't have any answers from you guys. I was waiting for your answer. Now let me tell you how to solve this one. See here, I'll solve this. Let us say I have to draw the influence line diagram for shear at point D. Now let us say here. So to draw the influence line diagram, what I will do? I will point a roller. So this will go down and this will go up. Now I have told you previously that whenever we have any support, that at support we have zero reaction. Similarly here at support it will be zero reaction. So can anybody tell me that if I take this point downwards and if I take this point upwards, how the influence line diagram is going to look? See here. Let us say this is point A, this is point D, and this is point B, right? This is 3, this is 5, and this is 2, and this is point C. Now, how to draw the influence line diagram in this case? See here, if I have to take this point down and here I have to keep it 0 and here I have to take this point up and here I have to keep it 0. So the only option left is, see, if I have to take this down, I will take this down and I will take it up, right? And then here it should be 0. It means how should uh, I have to, what is the option left? Let us say, see here, how I am going to draw it? I am going to simply join it with a straight line, and similarly I am going to join it with straight line. Now this is a overhang portion. So here at point C there will be some reaction. So it will come in the same slope, right? So it will be like this. It will not be big like this. See here. It will be simply like this. Right? So now what I have to do is I have to find out that what should be the value of, let us say, this alpha and this beta and let us say this gamma. Now how to find the value of alpha? Alpha value is going to be simply, see here, this is going to be 3, right? And this complete is 1. So this value is simply what? This value, this is nothing. And see here, from here till here, this is how much? 8 meters, right? So this alpha is going to be how much? Let us say this is 8 minus x, right? From here till here, it is already given. See, it is already given 3. And this one is alpha. So let us say this alpha is going to be how much? This alpha is going to be simply this 3 by this 8, right? And what is going to be this beta? This beta is going to be this 5 by this 8, right? And what is going to be this gamma? This gamma is going to be, let us say, this is 5 by 8 and this is 5. So 5 by 8 upon 5 is going to be equal to what? Gamma upon 2, right? So this gamma is going to be how much? Gamma is going to be 5 by 8. 5 by 8 by 5 means what? This will be simply 1 by 8 into 2. 2 by 8 means 1 by 4. So this gamma is how much? 1 by 4. So this 3 by 8 will be how much? This will be equal to 0.375. This 5 by 8 will be how much? This is going to be equal to 0.625. And this is going to be equal to 0.25. So what is asked in the question is, find the maximum ordinate at point D. So the maximum ordinate at point D is how much? Plus 0.625. See, it is in minus, it is in plus, this one is in minus. So in minus it is 0.375 and in plus it is 0.625. So what is going to be the correct option for this one? Correct option is going to be plus 0.625. I hope you all guys have got this correct option. And if you have any doubts, please ask. Yes, guys. So what I have done is, first from the given question, I have drawn the diagram. Then I have drawn the influence line diagram. And from this influence line diagram, I have calculated the maximum ordinate. So that was asked in the question, guys. So I hope I am clear to all of you. Yes. So let us see the next question. This is next question. ILD for shear force at section C for the given simply supported beam is. So this is the beam. See here. Let us say this is A and this is B. Right? This one is roller. So here somewhere it is point C. We have to draw what? We have to draw the influence line diagram for this one. So see, and for what? Influence line diagram for? We have to draw the ILD for shear force. We have to draw what? ILD for shear force at section C. Right, guys? So I have told you previously also how to solve it. Can anybody tell me what is the correct option for this one? By looking at the options, see, options are also given. You don't have to determine any value. You just need to see what will be the shape, right, guys? So I think it is very simple question. So try to answer this one. I have, previously solved a lot of questions like this. See, in my previous slides, I have told you how to determine the influence line diagram. So based on that only this question is asked. So anybody would like to tell me what is the correct option for this one? Yes, Shubhani, Manoj, Yash, Raju. Anybody would like to tell me how to solve this question? It is a very simple question. You know, anybody? See, I will give you some hints more. One, if you have to draw the shear force at point C, then whenever we have to draw shear force, what we do? We take roller support, right? So this roller support can go downwards in at left of point C and upwards at right of point C. So if you have to go downwards at left of point C and upwards at right of point C, then at the support, it is going to be 0, and this support, it is again going to be 0. So it will go down, it will go up, and supports, it will be 0. Now you have to simply, join it with the straight lines, right? So I think Sushmita has got the correct option. Correct option is option A. So hopefully I have been clear to all of you guys. So see, if I have to draw the influence line diagram for this one, that is A, B, and here it is saying what? C. So I will have to take it downwards at left of C, and I have to take it upwards at right of C. Then I know that here it is going to be 0 and here it is going to be 0. So I will join simply it with what? Straight lines. And this slope should be equal to this slope. Right, guys? So this is the ILD. This is what? Influence line diagram for shear force at point C. Right, guys? It will be minus and it will be plus. So see, the best option is option A. So option A is the correct option, guys. Yes, anybody has any doubts in this one? I think I have been clear to all of you guys. Now let us see the next question. ILD, what it is saying? ILD for bending moment at section C for bigly simple support. So see here, the question is, this is again a simply supported beam and this is point C, this is A, this is B. What we have to determine? We have to determine ILD. ILD is influence line diagram for bending moment at section C, or I can say point C, right? So see here, bending moment, point C. So for bending moment at point C, we have to find out what will be the influence line diagram. So can anybody tell me what is the correct option for this one? So I will tell you guys, if you have to find out the bending moment, see, if when we have to determine the shear force, what we used to do, we used to, put one roller and then we used to take it downwards in left and take it upwards in right. Similarly, if you have to draw the bending moment, then what we will do is we have to take one, theta like this and one theta like this. We have to rotate it, right? So from left we have to rotate and from right we have to rotate. So when we are going to rotate it from left and right, then what will happen? This during this rotation, this point is going to remain fixed and this point is going to remain fixed. So if these 2 points are going to remain fixed, then what will happen? This will simply, this beam, due to this, due to this angle, what will happen? Once you rotate it, this beam will come upwards like this. Yes, anybody, all of you, just see me in the video. What will happen if we rotate it? If see, this is one straight beam, right, guys? This one is what? This one is a straight beam. If I have to rotate it like this and like this, so what will happen? This beam will go up. So how this beam is going to go up? Once I have to rotate this in this direction and in this direction, this beam is going to go up, right? So see, whenever we have to draw the influence line diagram for a reaction, then for bending moment at any section, then we give theta in this direction. So due to this theta, this beam goes up, and here it is going to remain at the support only, right? So this is the diagram for bending moment at any section C in case of a simply supported beam, right guys? Now can anybody tell me what should be the value of this ordinate, right? We have to find out, let us say this is x. So what should be the value of x? Or how can we find this value of x? So I will tell you a simple trick. Let us say that this distance is how much? Alpha. And let us say this distance is beta. Right guys? So this value of x will be how much? Alpha into beta upon alpha plus beta. Alright guys? Always remember that this value of x will be how much? Alpha into beta upon alpha plus beta. And this alpha plus beta is what? This is alpha and this is beta. So this is going to be the value of this x. So looking at the options, what is the correct option for this one? The correct option is option B. Right guys? So I hope I am clear to all of you. Now let us move on to the next question. Next question is ILD for shear force at section E, right? So see here, this is the beam, this is point C, this is point A, and at point A we have a reaction. This is point A, this is point E, this is point B. Again at point A we have a reaction, and this is point D. What we have to find out? We have to find out ILD for shear force, ILD for shear force at E. So remember shear force at E. So using the Muller-Breslau principle, we are going to apply. So whenever we have to find out the shear force at E, see here we have to find out shear force at E. So we are going to apply like this, right? So just take some time, try to tell me. See, I've given you enough hints. Just apply this. So this will go down, this will go up, and here it is going to be 0, and here it is going to be 0. Now tell me guys, which option is going to be the correct option? Try to draw it on pen and paper. Try to draw it. Try all of you, please try, and then tell me what should be the correct option. I have given you enough hints, guys. Yes, take some time. I want you to solve this question. This is, very simple question. I have already solved many questions like this earlier. So try to tell me what should be the correct option for this one, guys. I'm giving you some time. Yes, I'm waiting for your answers. Has anybody got any answer? Smita says option A. You are absolutely right. Option A is correct. Yes. Well done. Anybody else got this option? Okay, so let me solve it for you guys. Let me tell you how to solve this question. So see here, I have told you already that if you have to determine the shear force at point E, see here we have to determine the shear force at point E. So we are going to apply this roller. So at the left of point E, this is D, this is B, this is E, A, and C. So see here, at the left of point E, it is going to go down, and at the right, it is going to go up. Now here it is going to be 0, and here it is going to be 0, and this slope should remain same, right? It means this slope and this slope should remain same. Now what will happen to next? So this slope is again going to remain same here. So again this will be extended up to this, and this will be extended like this up to this. So this is point C, this is A, this is E, this is B, and this is D. So see here, it is minus, it is plus, it is plus, it is minus. So in all these options, what is the correct option? Option A. So Sushmita got it right. Yes, all of you should have got this correct option. So I've already given you enough hints that how to draw the diagram for this one. Now let us see the next question, guys. ILD for shear force at support A. So same question is there. The thing is, matlab same diagram is there, but they have asked for different point, right? So see here. Yes, Shushmita, try to solve this. All of you, please try to solve it. Try to tell me which is the correct option. I am drawing the diagram. There is one support at B and this is point D. Now, what the question says, we have to determine ILD for shear force at support A. Right, guys? It means in this case, we have to find out the shear force at support A. So see, this is the shear force at support A. So when we have to find out the shear force at support A, it means we have to apply one roller here, and this roller will go down in this direction and this will go up in this direction, right? Right, guys? And what will happen naturally? So this will go down, this will go up, and here it is to remain 0, right? At point B, it should remain 0. So can anybody tell me what is the correct option for this one? Yes, can anybody tell me what is the correct option? Yes, anybody would like to tell me? So see, if you know, okay, I'll tell you how to draw it. See here, this is point D, this is point B, this is point E, this is point A, and this is point C. Now, at point B, we know that the ILD is going to be 0, right? And at point A, there is one reaction here. And at this reaction, we have to apply this roller, right? Now, we also know that whatever slope is going to be this side, the same slope is going to be this side, right? And here it is going to be, and here it is going to remain 0. So let us say that at point A, it goes in the upward direction to the right, and at point B, it is going to remain 0. So it means it is going to remain somewhat like this, right? This is going to remain somewhat like this. So now, whatever slope is this slope, the same slope is going to remain this side, right, guys? So how can we get the same slope this side also? If we are going to extend, see, if we are going to extend it up to this point, then only we are going to get the same slope, right? See here, if we are going to extend it up to point C, then only we are going to get the same slope at this one. So this is going to be the influence line diagram. and similarly we are going to have the same slope this side also. So to get the same slope, it is going to be drawn like this. So see, the same slope is going to be this side also. So if we have to apply the reaction at point A, then how the influence line diagram is going to look? It is going to look like this. See, this is a continuous straight line. So this one is the correct option. Yes. So option C is the correct option. So always remember guys, whenever we have to draw the shear force at any support, right? See here, this was at support A. So whenever we have to apply at support, then to keep the same slope, it is, extended in the same direction, right? So we will see some numericals also on this one. I hope I am clear to all of you guys. Okay. So let us see the next question. Anybody has any doubts here? Please ask, or you can post it in the chat box also. Now, see, based on similar concept, you have to determine what? You have to determine the ILD for shear force at support B. Now, at this support B, I am going to apply the ruler. So you have to determine what is going to be the ILD. ILD for what? ILD for shear force. ILD for shear force at support B. So using the same concept, I told you here, use the same concept and try to find out how the ILD or the influence line diagram is going to look. Yes, yes guys, you can tell me what is the correct option. See, similar concept you have to use. Just now I have told you that if there is a support and at the support you have to find out the shear force, then using the Muller-Breslau principle, you can apply and you can get it. So see, I will give you one more hint. The hint is at point A. At point A, what will happen? The shear force is going to remain 0, right? So see, in all these options, in this option, it is 0 here. In this option, it is 0 here. In this option, it is not 0. It means this option is wrong. This option can also be right. So these three, it is there. Similarly, at B, whatever slope we are going to get this side, the same slope should be this side, right? And the same slope should be this side. So can anybody tell me what is going to be the correct option? And at BC, this cannot be happen, right guys? This cannot happen at B. What? Because if you are going to apply some shear force here, then it is either going to go up or it is going to go down. But it cannot remain at 0, right? So see, this option is also wrong and this option is also wrong, because see here it is showing that it is 0, but it cannot be 0, right? So these options are also wrong. So this option is also wrong. So what is the correct option left? I think Sushmita has already got the correct option. Correct option that remains is option D, right? So using the similar concept here, you could have easily drawn the shear force ILD for shear force at B. So see here, I am going to use the same concept that just now I told you. This is my point C. This is my point A. This is E. This is B. And this is D. Now, what will happen? We are going to apply one force here. So if we are going to take it upwards, right guys? And here we have to keep it 0, right? So see here, from here, what will happen? From here till here, it is going to go like this. And same slope we have to maintain. So it is going to get extended like this. And then same slope we have to maintain this side also. So it is going to get extended like this. So here it is minus, here it is plus. So what is the correct option for this one? Option D. So I hope you all guys have got the correct option for this one. Now let us draw. Let us see the next question. The next question says that ILD for shear force at the section just right to the point A. Now, see here, in one question, what we have seen is that we had to find out the shear force for ILD for shear force when we had to apply the reaction at A, right? But here what it is saying that we have to just find out at the right of point A. Let us say this is the left of point A and this is the right of point A. So at the right of point A, we have to find out the ILD, right? We have to find out the ILD for shear force just to the right, just to the right of point A, right? We have to find out the shear force. We have to find out the influence line diagram for shear force just to the right of point A. So let me tell you guys, let me clear here that this question is different and this question is different. In this question, we have to find out the ILD for shear force at point A. But in this question, we have to find out the ILD for shear force just to the right of point A, right? So it means we are only going to apply the shear force. See here, what we are going to do in this one, we are going to apply the shear force by taking it upwards. We are not going to take it downwards, right? So we have to only take it upwards and to the right of point A. So to the right of point A, we are going to apply one roller and we are going to take it upwards. So can anybody tell me what is going to be the correct option for this one? Sushmita says option A. I don't think option A is correct option. Option A is not correct. Okay. So let me tell you, this is, very interesting question. So let me solve it for you guys. See here, this is C, this is A, this is E, this is B, and this is D. Now, what we have to do is we have to take a unit load. We have to take one roller just to the right of point A. So just to the right of point A, I will take it upwards. See here, just to the right of point A, I will take it upwards. Unit load, I will apply one unit load and I will take it upwards. So this I have taken it upward. Now I know that at point B, there is one support here. So if there is one support here, it means at point B, it is going to remain 0. So it is going to remain 0. It means this is going to be like this. See here, this is going to be like this. Then if we have to keep the same slope here and this side, it means we have to extend it like this, right? So this is the diagram up to this point. Now, if you have taken to the right of point A completely, then to the left of point A, what we are left is 0, right? Understand? Get it here. Yes, Shushmita, option B is correct. See here, if we have to, get to the right of point B, the complete one unit load, then to the left of point A, what we are left with no unit load. It means to the left of point A, it is going to remain 0. And now we have to take the same slope like this to the left of point A. So what will happen if we take the same slope? It is going to go like this, right? So the correct option for this one is this diagram. That is option B. So Sushmita got it right. So anybody else has got the correct option, guys? All of you must try it. These are very interesting questions and these are very, conceptual questions. So these questions are mostly based on what? These questions are mostly, you can easily, solve these questions. See, what I am doing is I am not solving much. But if I am clear that how to apply the Muller-Breslau principle, then I can easily get the correct options. As you can see, all of you can see here, that what I am doing is I am simply applying the Muller-Breslau principle. If you simply apply the Muller-Breslau principle, you can easily get the correct options. Right, guys? I'm also trying to give you enough hints to solve this question. So let us see the next question, guys. Anybody has any doubts, please ask. Now see, what we have to determine is influence line diagram for bending moment at section E. It means at this section, we are going to apply theta here and theta here, right? So I have told you how to draw the ILD. I have told you already that how to draw the ILD for what? For bending moment in simply supported beam. So this one is what? Overhang on both sides. This is a simply supported beam up to point AB, and it is overhang this side. This is overhang this side. So just try to find out using the same logic that I told you while determining the ILD for bending moment in simply supported beam. So in this case, we have to determine at point E. So see here, at this point, the bending moment is going to remain 0. And at this point, the bending moment is going to remain 0, right? So out of all these options, in this option, at point A, it is not 0. It means it is wrong. Similarly, at this point, it is not 0. So this one is also wrong. So either this or this. So this one is for what? This one is for shear force, if you remember. So this one is also wrong. So the correct option is what? Option B. I think Sushmita got it right. Option B is the correct option, right? So this was what? This was by doing option elimination, but we don't have to do this. If we can, get the correct option, then why we need to apply this? This was, a shortcut way to get to the option. But let us try to find out in a correct way. So by applying the Muller-Breslau principle, I told you guys that let us say this is C, this is A, this is E, this is B, and this one is point D. Now what we have to do is we have to apply a movement like this and a movement like this. So this beam will go upwards like this, right? So see here, and we have to keep it 0 here and we have to keep it 0 here. So the only option is how it is going to get? It is going to get like this. Now we have to keep the same slope here till here. So in overhang portion, it is going to get extended. Similarly, we have to keep the same slope here. So in this overhang portion, it is again going to get extended. So like this, we can easily draw and we can easily get the correct option. So the correct option here will be what? Option B. So I hope these are very interesting questions and I hope you guys are, solving it with me. And whatever doubts you have, please, post your doubts in the chat box. I'm here to, solve all your doubts. Yes, guys. So let us take you to the next question. Now there are some numericals, right? Here, what we have done is we have learned how to, solve the or how to draw the diagrams. Now let us try to, use those diagrams and try to find out the, correct options in these cases or try to find out some numericals. So choose the correct influence line diagram for the shear at point C. So see the values are also given. Now you have to tell me that which option is correct. You have to also determine the values here, right guys? So I have already told you or you already know how to determine the influence line diagram. See, you have to determine influence line diagram for shear at point C. Now you just need to tell me. So I think you guys already know this is point C. So how to draw the how to find out the influence line diagram in this case? To find out the influence line diagram, we will apply what roller at this point. It will go down, it will go up. So just try to find out the try to find out the ILD. So to find out the ILD, this is point A, this is point B, and this is point C. This is how much? This distance is 2 and this distance is 8. So I told you already guys that to find out the ILD, it is going to remain like this and here it is going to go up and here it is going to be 0. So the diagram is going to be like this. Now what you have to tell me is what is the value of this alpha and what is the value of this beta. Once you know how to get the value of this alpha and this beta, then you can tell me which is going to be the correct option. So it is all either going to be option A or it is either going to be option B. Option C and option D are wrong answers. Now, can anybody tell me how to get option A or option B? Can anybody tell me how to get the value of alpha and how to get the value of beta? Okay. Can anybody tell me? See here, guys. how to get this value of alpha and how to get this value of beta? Always remember, see here, let us say that for a moment, let us say this is x and let us say this is y, right? So what is the value of this alpha? This alpha is going to be how much? X upon x plus y, and this beta is going to be how much? This beta is going to be y upon x plus y, right? You can get it from the property of similar triangles also. See here, how to get it from the property of similar triangle, guys? See, very simple. Let us say that if we apply the property of similar triangle in triangle this and in triangle this, then can I say that what alpha by x, can I say here that alpha by x is equal to what? Beta by y. And I know that x plus 1 is how much? X plus y is how much? 1. Sorry, alpha plus beta is how much? 1. So using these two equations, you can find out this alpha and this beta. Once you solve these two equations, then what you will get? You will get alpha as x upon x plus y and beta as y upon x plus y. So in our case, this x was how much? This is 2 and this is 8. So how to find out alpha? This alpha will be how much? This x is how much? 2. So this will be 2 upon 2 plus 8. That is 2 by 10. 2 by 10 means 0.2. Similarly, this beta will be how much? Y upon x plus y. Y means what? 8 upon 8 plus 2. That is 8 by 10. Right, guys? So this beta will be how much? 0.8. So what is going to be the correct option for this one? Option A. Yes. Anybody has any doubts in this one? So I told you how to find out this alpha and how to find out this beta. So here, this one is very important. Try to remember it, how to find out the ordinates of these 2 points. Right, guys? So let us move on to the next question. What we have to determine? We have to determine, choose the correct influence line diagram for the bending moment at point C. Yes, I'll give you some time, guys. Try to solve this question. See, I have already told you that whenever we have to determine the bending moment, what we do is we apply theta, right? So once we apply theta, it will go up. So I have told you that, let us say this is point A, this is point B, this is point C. So it is going to go up like this, right? And it is going to go like this. Now the only question remains is, what is the value of this alpha? Right, guys? Let us say this is x and this is y. So I have told you this also in the previous slides. Can anybody tell me what is the value of this x? Yes, guys. Can anybody tell me what is the value of this x? See, I have told you in one of the slides here. See here, I have told you that let us say this value is alpha, this value is beta, and let us say this value is x. So this x is how much? This into this upon this plus this. This x is how much? Alpha into beta upon alpha plus beta. Right, guys? So see, in this current question, okay, Shushmita says option D. Option D is the correct option. You have got the correct option. So this alpha is how much? This alpha is nothing but x into y upon x plus y. So in our case, this x value is how much? 2 and this y value is how much? 8. So this alpha will be how much? 2 into 8 upon 2 plus 8. It means 16 by 10. That is 1.6. So see, 1.6 is the correct option. Right, guys? So I hope you have learned it how to apply. Let us take one more question. Now the question says the ratio of ordinate value at point A and at D for, see, what ILD we have to determine? ILD of vertical reaction at D. So here if you have to apply vertical reaction at D, then we have to find out the ratio of ordinate at point A and D. So first and foremost, what we have to do? We have to find out how to draw the ILD of vertical reaction at D. So see, in this slide, I told you that how to find out the ILD for shear force at support B. See here, when similar diagram is there, there is one shear force at support B. This is the ILD. So from this ILD, what they are asking is, they are asking the ratio of these ordinates. Right, guys? So this you have to apply here. Okay. So try to apply in this case. So from this diagram, so whenever we have to find out the, of the vertical reaction at D, so what we are going to do, we are going to apply a vertical reaction here, right, guys? So once we have to apply a vertical reaction at point D or a roller support at point D, then let us first draw the ILD for this one. So let me draw it here only. So how to draw the ILD for this one? Let us say what will happen. Let me draw it here. This is A, this is C, this is D, and this is B. So once we have to draw, we will take one shear, we will take it down, we will take it down. So once we have to take it up, then how it is going to, and here it is going to remain 0. So what will happen? Let us say it is going to go like this. Right, guys? And similarly, here it is going to go like this. Now, the question, what does the question says? Let us say this is 2, this is 8, and this is 4. Now, in question, what is asked in the question? See here, the ratio of ordinate value at A. So let us say this is alpha, and at D, let us say this is beta. So the ratio of alpha by beta is asked, right, guys? By taking the modulus of each value. So see here, it is going to be negative and it is going to be positive. So we have to take the, modulus value. Modulus value means we have to take the positive value of alpha. So this ratio we have to determine. It means what? We need to determine what is the value of alpha and what is the value of beta. Now, how to find out the value of beta? So see here, this beta, this complete is how much? 1 unit load. And this one is 8, right? Let us say this one is gamma. So can I say that this slope is equal to this slope, right? So it means what? This alpha value, let us determine this alpha value. This alpha value will be how much, guys? This alpha will be from this triangle and this triangle. Can I apply the similarity of triangle principle here? So if we apply similarity of triangle, can I say, let us say that this is point, P, Q, C, then this is R, and this is S. So let us apply similarity of triangle in PQC and triangle, which one? CRD. So if you apply in these two, then what we will get here? See, this alpha by this 2. I can write this alpha by this 2. This will be equal to what? This beta by this 8, right? This beta by this 8. So from here, can I say that this alpha by this beta will be equal to what? 2 by 8, right? So 2 by 8 will be how much? 1 by 4. 1 by 4 is how much? 0.25. So what is the correct option for this one? Correct option is simply 0.25. What was asked in the question? Alpha by beta value was asked. Right, guys? So I hope I have been clear to you. Yes? If anybody has any doubts, please ask me. Shall I take one more question? Or shall I not take one more question? Okay. See, the maximum, okay. This question is for the similar diagram only that we have solved it here. So let us try to solve this question also. What it is saying is the maximum ordinate value. See, maximum ordinate value of the ILD for vertical reaction at D will lie on. So see, in this case, we have drawn this. This is what? This is the ILD, right, guys? So this is the influence line diagram. So in this influence line diagram, what they have asked is which of these, wherever, like if this is point A, C, D, and B, at which point the ordinate value means what? This vertical reaction, where it is maximum, right? Where this ordinate value is maximum. So can anybody tell me where this ordinate value is maximum? If you look at this diagram, you can simply say this is 1 and this is going to be, bigger than this one. So if you have to find gamma, then I can use the principle of similarity of triangle in these two triangles, right? So in these two triangles, let us say, if we have to find out gamma, then can I say from here that, let us say that this beta by this 8, this is going to be equal to what? This gamma by 12, right? So it means this gamma is going to be how much? 8, sorry. This gamma is going to be how much? 3 by 2 times of beta, right guys? This gamma is going to be 3 by 2 times of beta, and this alpha is going to be 0.25 times of beta. It means beta is how much? Beta is 1. It means this alpha is 0.25 and this gamma is how much? 1.5. So which is having the maximum ordinate? The maximum ordinate is of gamma, right guys? So the maximum ordinate is of gamma, and how much? It is 1.5. So what was asked in this question? What is the maximum ordinate value of ILD for vertical reaction at D? So it is lying at which point in this diagram? It is lying at point D, and how much? 1.5. So which option is going to be the correct option? Option B. That is, it will lie at this point. And the diagram will be how much? The ILD diagram will be somewhat like this. Right, guys? So this will be 1.5. This will be 1. And this will be how much? 0.25. This will be minus and this will be plus. So this is going to be the ILD. That is the influence line diagram. So I hope I have been able to solve all these questions. Yes. And I hope I have, solved too many questions from the topic of ILD. So if anybody has any doubts, I am still here, guys, to take your doubts. If you have any doubts, feel free to ask me. You can post it in the chat box. See, I have solved too many questions here. I have tried to, take you through like how to draw how to, best make use of this Muller-Breslau principle. If you apply this Muller-Breslau principle, you can very easily, get to know that how to draw and how to determine these values. So anybody has any doubts? Yes, please ask me, guys, because this topic of structure analysis is very important if we talk it from the point of view of GATE examination, right? See, I told you guys in starting only that it covers almost how much marks? 6 to 8 marks. So these 6 to 8 marks are very important. And this topic of structural analysis is not very tough to understand. If you apply the logic and if you apply the principles well, then you can very easily get the correct options. Yes, I am still waiting for your doubts. If anybody has any doubts, please ask me. Otherwise, I will say good night to all of you. Yes, guys. Okay, so shall I end the lecture? Okay. So I hope I have solved all your doubts and I hope, it was a great lecture, guys. So good night, all of you. We'll see you in the next lecture. Okay, guys. Thank you. Thank you all.